Hi guys, one last video. My family is home, so sorry if there's background noise going on here. Hopefully we won't have screaming like the last time. So Unit 10 Part 4 is Probability and Statistics. This is probably the hardest part about Part 4. In Probability and Statistics, we are going to be looking for probability, which is what you're looking for, what they ask you to look for, over the total amount of possibilities that there are.
Yeah.
So, hey, that was my Mother's Day gift from Gia. Don't do that, okay?
Okay.
Are you making it nice? Alright. Well, she's burning the gift that my older daughter gave to me. So, here's a chart. This is a chart that gives you the sum of rolling 2 die. So, here are the different faces of the die. You have 1, 2, 3, 4, 5, and 6. Ta-da! So the sums of these are 2, 3, 4, 5, 6, 7. All of these are your different possibilities when you roll a die. Okay? So when you roll 2 dice, there are 36 different possibilities of sums that you could roll. So you're asked the probability of rolling a 7. So I just told you that when you roll 2 die, there are 36 different possibilities. So the total amount of possibilities are 36. You have to figure out how many 7s show up. So I have 1, 2, 3, 4, 5, 6. So I was looking for the probability of rolling a 7 out of all the different probabilities of the sums when I roll 2 die. So you use your ABC key in your calculator. So 6 ABC 36. You get 1 6 out there, okay? Another probability. They ask the probability of rolling a number divisible by 3. Again, there are 36 different probabilities here. A number divisible by 3 means that 3 goes into it evenly. So that's 3, 6, 9, and 12. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 out of 36 numbers are divisible by 3.
Mommy.
What? Your face is messy and so is your hair. Okay, do not do that. Oh, okay. You want me to write? Okay. You gotta stop. Okay. No. Stop.
Stop.
You stop.
Oh.
Okay. So then 12, ABC 36, when you reduce it, that's 1/3. So 1/3 is your probability of rolling a number that is divisible by 3 here. On to the next. So this says the probability of 2 things happening at once. You have to find the probability of each individually and then multiply them together. So for example, what is the probability of flipping tails on a coin and I guess I should say rolling, sorry. And rolling an even number on a die. So on a coin, if you flip it, you either get heads or tails. So there's 2 different possibilities, 2 different outcomes there. One of the outcomes is tails. On a die, if you roll 1 dice, there are 6 sides to a die. Sorry.
Stop.
And on it, you have 1, 2, 3, 4, 5, 6. They're the different faces. So the amount of even numbers on a die is 2, 4, and 6. So there are 3 even numbers. So you have to multiply these two together. Will you stop, like, drinking like that? Over the total amount of possibilities. ABC that bad boy, and you should get 1 over 4. Okay, there's another one that I have on here. Alright, let me turn it like this. You could pause it if you need to read it. There are 4 pink balls and 1 brown ball in a small jar. Also, 3 pieces of gum and 2 mints are in another jar. If Bill draws 1 item from each jar without looking, what is the probability that he gets a brown ball and a mint? So, you have 2 different jars. In the first jar, this is the one with the balls in it. You have 4 pink and 1 brown. So there are 5 total balls in there. In your second jar, or jar 2, this is with the gum and mints. Stuff to make your breath smell good. Don't shush me. Shh. Don't shush me. In that jar, there are 5 items, 3 pieces of gum, 2 mints. So 5. We're looking for the probability that he will get a brown ball and a mint. So we're looking for the probability of brown and mint. There's one there's 1 brown ball. I'm sorry. Out of 5 in the jar. And there are 2 mints out of the 5 items in the second drawer. I can't stand it. What are you doing? Why did he make you do that? I'm trying to teach. What are you smelling?
Bad.
You smell bad? Where's your shirt? Go get a shirt on. You smell my foot? Can't stand you guys. So that's 1 times 2. No, don't do that. Over 5 times 5, which gives us 25. So the probability of pulling out a brown ball and a mint is 2 out of 25. All right. And our last type of problem here on probability and statistics. It's if I conducted an experiment here. Hold on, I'm sorry. Jesus. Stop, watch your hand. You're bad. If you conduct an experiment, I don't know what kind of an experiment, but if you're ever given a chart, here's the number and the number of occurrences. I think I spelled that wrong. Sorry. Oopsies. It's supposed to be an E. Whatever. I'm not an English teacher, right? So the number 0 occurs 6 times, the number 1 occurs 5 times, the number 2 occurs 15 times, and the number 3 occurs 12 times. The question is, according to this experiment, what is the probability of getting a 1 or a 2? So, in this case, when you're asked for this, you have to take all of the occurrences. So you have 6 plus 5 plus 15 plus 12. So there's 38.
Okay, Mommy.
Right?
I can
Yeah,
Mommy.
there's 38 there. Okay.
Gosh.
So a 1 or a 2 5, 15,
My tick.
is
Shadow.
20 over 38. Which gives you, that'll reduce if you use
Mommy.
ABC key. What, honey? That'll give you 10 over 19. Okay. So,
Mommy.
what, honey?
My tick is shadow.
What?
I just circle. This is I
Oh.
think shadow.
You drink soda.
Yes.
That's my soda.
My shadow.
That's my soda.
My shadow.
For the record, it was my soda. I don't give my kids soda. That's a lie. I sometimes do if she's bothering me. Anyway, so that's the the probability and statistics part of that. Something I'm not sure I showed in Unit 10 in the curriculum. We go over mean, median, and mode, and we've touched upon these in these videos. Another child. The mean is your average. So to find the average of something, you add them all up, and you divide by the amount of numbers that there are.
Hey.
The median is the middle number once you order them from least to greatest, and the mode is the number that occurs the most often. Okay.
Honey.
We talked about range. That's your biggest minus your smallest. And all of these are measures of central tendency. So a perfect representation of data where the mean, median, and mode are all the same is, like, say you're given a line plot. Let me make up a fake line plot. I'm sorry, hold on. You're gonna take my word for this one, but if you wanted to do it, you could figure it out. Sorry. Let me put numbers here. 1, 2, 3, 4, 5, 6, 7. If I were to fold this in half right here, it would fold perfectly. It's perfectly symmetrical if I cut the data right up the middle, okay? Anytime your data looks like it's represented perfectly symmetrical, that means that your mean, median, and mode are all the same, okay? This, if I were to draw a bell-shaped curve over here, it's a perfect bell-shaped curve. It doesn't look perfect because I'm drawing it. But if your data is ever symmetrical, then your mean, median, and mode are all the same. Okay, so you don't even have to try. You could add up all these together. 1 plus 2 plus 2 plus 3 plus 3 plus 3 plus 4 plus 4 plus 4 plus 4 plus 5 plus 5 plus 5 plus 6 plus 6 plus 7. My husband's making fun of me and I don't like that. And divide by the total amount of points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. But what you'd get for the average is 4. What you get for the median is 4. What you get for the mode is 4. So anytime your data looks perfectly symmetrical, all of these measures of central tendency are going to be exactly the same. And if you're looking for the range here, it's just 7 minus 1, which will give you 6. All right, I think that is it for units 9 and 10.
You're all gonna get zeros anyway.
That's so nice or encouraging. You're all going to do great. I'll see you on
Probably
Friday.
You're all probably
Check in to make sure I'm not putting up any more videos. But I think we're good. All right, see you guys later.